Good day everyone. So we will have now our pre-lab for experiment 2, which entitled First Condition of Equilibrium using Tension Protractors. The objective of our discussion today is to verify the first condition of equilibrium, in which this is the summation of all forces should be equal to 0. In this experiment, we will have three forces. They are the force of the right string, force of the left string, and force of the center string, in which the summation of that should be equal to 0. So the setup will be like this, okay? So we have here two tension protractors, this one, and this is the other one, and we will have the hang mass, okay? Now, this tension protractor will read the force of this string, so we call this as a left string, so we will call this as your left string. For these tension protractors, this is connected to this right string, okay, so we will call that as your FR. And this mass, so we will have to convert it to Newton later, so we will call this as your force center. Based on the data on your experiment, we will complete table A. So we will have here, so the magnitude of the left chord and the right chord, we have to read the tension protractors, while for the magnitude of the force for the center chord, since the center chord here is in terms of mass, okay, so we have to convert it, in which force is equal to mass times gravity, in which mass here should be in kilograms, while the gravity is 9.8 meter per second squared. So you have to compute that. So the green square here means you will use the green formula. All the angles here should be in polar coordinates, okay? So all angles measured from positive x counterclockwise. So later on, I will explain this. So let's focus first on how to use and read tension protractors. Now, these are the example of tension protractors we will use. So, if there is no hang mass, okay, the reading is 0. And if we will put a hang mass here, so it will move clockwise. So, that reading here, okay, so this will be 0 Newton, 1 Newton, 2, 3, 4, 5, and so on. So, the reading will be clockwise and in Newton. Now, in this case, for this example, so it is exactly at this between 0 to 1. So we read this as 0.5 Newton. So other than the force, we will also read the angle. So for example, this one, this is the string. So aside from the force that we will read, we will also read the angle. So this is the string, okay, which is the angle. Now, if we will go back here, so for example, this is the string, okay, of the angle. So the reading there is 30 degrees in the protractor, but the basis of that will be if this is your x-axis, so that is from negative x going clockwise to 30 degrees. So that is how to read. So let's talk about how to read the angles. So we will assume our tension protractors. So the 0 is at 0 degrees. And we will have here the x-axis of our point of interaction. What are we going to get is the angle. So if I will write here, so I have to get the angle between this. So we call this as your theta r. Okay? So this is the angle of FR reference to the positive x. To get theta r, since we know that, for example, this is 30 degrees, so whatever the angle of this is also this angle. The next one is how to find the angle of the left chord. So we will have from positive x again going to this chord. So what that is our left chord. Based on what we know in math, whatever the angle here, okay, so that whatever the angle there is also the angle in this position. Okay, so this is for the protractor. So to get the theta left, since we know from positive x to negative x is 180, so 180, okay, degrees. So we will just subtract to the angle we know here, which is based on the protractor reading, and that will be now the angle of our left. And for the center angle, we will just have the angle from positive x going to negative y, which is equal to 270 degrees. Okay, so once we complete our table, so the magnitude are complete, the angles are complete, we can now proceed to the next part of your data, which is this, okay, the graphical method and the component method. For graphical method, I expect you to have this type of triangle in which if you will connect FR, FL, and F center, okay, graphically, you will have a closed triangle. So it means there is no resultant force, or the resultant force is very, very small, to assume that it is insignificant. Now for component method, so you will just substitute all your magnitudes here in Newton, and also what angle you get here, and definitely the center is 270. You will get the x components by solving magnitude, cosine, angle. That will be your component on x, while for the y component, that is magnitude, sine, the angle, so that will be your. So once you add all the x components here, so we will have here the rx. So I expect we will have the rx here, and the summation of that rx should be equal or near to 0. Same with this, we will you have to add all your components on y, so the answer here should be also equal to 0 or near to 0. Now, we will use the values of this rx and ry to find the magnitude. So that will be square root of rx squared plus ry squared, which is, I expect, should be equal to 0 or near to 0, since we expect that the summation of forces should be equal to 0. And for the angle, we will use the arctangent ry over rx. Just solve whatever you solve here based on your data. So that will be for the component method. So you have to show your calculation on page 47, and you have to answer the questions stated there. There are 4 questions, so I hope you can complete that at the end of the class. On the next video, please watch the experiment for experiment 2 and get all your datas from there. Thank you.